Okay, so I stuck this in some muriatic acid. I kind of filled it up and cleaned the inside. You can see the band that's missed. I really should sandblast them. And then I flipped it over and stuck it in the other way. Cleaned the outside. Did it with both of them. You can see the line of the water, or the level, the acid level. Remember, if you do this, you got to neutralize your fill a 5-gallon bucket with baking soda and water and drop that in. I'm fortunate enough that I have that powder coat oven, so I baked it off. I just set it at 280 degrees, something significantly above boiling, and then baked it off so it wouldn't sit in flash rust, as much. So now, anyway, what am I talking about? So I want to get these. I love these bullet style headlights. These are 30-something Oldsmobile headlights. So they stood off the fender on a 2-inch socket, and then they were wired in. You can see in front of the, and whatever was there to establish that. I believe the wiring just hung freely, and that I don't want to do. So I have to establish a ball and socket arrangement so that you can adjust the headlight. But I want my wiring hidden, and it's going to come up through the post. So now I need to make a method of mounting these headlights on. And I'm thinking to go with, I want to curve up, and then have the ball and socket arrangement where there's an adjustment nut possibly sunken in somewhere into that curve, but remembering that I have to get my wiring through there as well. So I'm playing right now with a concept. So I got some 1-inch DOM, 1/8 wall, so 3/4 inch ID, plenty strong, marked it off on 1-inch increments. And now what I'm gonna do is I'm gonna scribe a line on it. As long as I hold this level. So that'll establish, I can see it, but I'll turn this light on. There you can see it. So that'll establish a constant center line, so I can keep that eyeballed up. I can put it on one side or whatever. And then I mark the position, roughly the center line there. Doesn't matter as long as I stop in that position every time. So these are notorious, right, for kinking the tube if you try to do a full-on bend on them. And so what I'm going to do is I'm going to move it and count my pumps, whatever, 5 pumps, 5 pumps, 5 pumps, whatever it is, all the way down the pipe until I get somewhere in the neighborhood of 90 degrees. I'll split it. Again, I got my distances. I need that tail because I got to get underneath that roller, right? So from here to here, somewhere in there, I'm going to get something close to 90. I'll find the middle, cut it, and then I'll have 2 pieces that are mirror image of the other. So that's the plan. Going to go ahead and try to roll some of that up and see what happens. I'll get back with you. So that worked quite well. You can see just a slight amount of narrowing on there. It realistically, that'll sand out. I don't know at this point if I'm going to do covers for it or whatever, if I'm going to cover it up with a 3D printed thing for styling. But this is worth a shot. It's a little, trying to get a perspective on it. See, it's a little sharper than 90. And you can see it narrowed just a little bit. But what I did was then I just, again, in this case, I went 4 pumps every inch. But then I came back and I went 4 pumps in the middle. So every inch, but in the middle. So I came back and did it. The results were really good. I mean, you can feel it. It's hard to see, but you can feel it. And it did widen out by comparison and narrow up as it formed around, that bottom die. Now, I have my marks. See, I got all my marks. and I know where I stopped. Where is it? I identified it. So I'll go, you know, whatever, a distance beyond that, cut it off, a distance beyond on the same here. This is where I started. I don't have lines, or I started right there. I started on the first line, so I can measure the same amount, you know, if I go an inch or whatever. But I know where I ended, I know where I started, and so now I can determine how high up before the radius, slice it in the middle, and get a position for those headlights. Now, I don't need to necessarily enter into this, you know, with a true vertical. It doesn't need to sit like this. I mean, for me, it could sit like this. It could sit anywhere I want it to sit, but I'm thinking about clocking it a little bit because I can re-drill the mounting holes and whatever. And depending on how I want that spread to look and all of that kind of thing. But I also want to do some sort of a crossbar. You know, I want to come across. So I'm gonna play with it a little bit. And again, if it doesn't work, whatever. I'll start over with a different plan. But this is what I'm shooting after right now. All right, so there is the bent piece. And what I did is I traced over the piece before I cut it. That's where I stopped, that's where I started. I folded it over. Okay. And then I took the edge that was hanging over, I think it should be on here. You can see my pen line. Come on. You can see my pen line right here, right there, and then right at there it just drifts off, and this is the pen line on the bottom. That's just drawing it on the table. I needed adjustment on this leg. I know it was this side because that's my start. So I folded it in half to establish my center line. This curve was a little sharper than this one. Okay, so I left the profile like this before I cut it and bumped on this one a little bit until I got that profile. I'm symmetrical. When I hold it in half, I'm a symmetrical pattern. So then I cut the two pieces. I cut the legs off first, the length off first. So I've got symmetry. I cut the length off. I don't have it perfectly centered and all that right now. I kept okay, and not concerned about what the pitch is on these cuts, whether they're perpendicular or anything at this point. Just right now have two identical pieces. Now I'm going to make these shoes out of, this is 1/8 inch. I'm going to make these shoes out of 10 gauge and then work on how I want to clock this, and I'll trim this size. So I'm going to cut the shoes out on the plasma table. I scratched out a quick drawing. I know my center to center is 2/125. I need a 1-inch hole because I want this to slip in or press in. Even if I have to grind or sand a little bit off of that, tap it in to bottom. And my bolts are 3/8 on each side. I'm going to do a 44 or you know, just a little bit better than 7/8 radius. Now you're thinking, oh, those are going to look like shite on there. Again, I want to do a 3D printed cover that will do it in 2 halves, snap it together and put it on there. And I still need to, of course, dress how I'm going to interface with that. So that's the phase that I'm at. I'm going to jump on the computer, quick draw that up, and cut 2 of those shoes out. Okay. Wow. What the heck am I doing? Back up a little. Okay, so I tacked this on 2 spots. Right there right there, 3 spots, right back there. I touched it there to hold it, right there, and in the back. Before I did that, I took the 2 ears that I plasma cut out and I tightened them down on the fender so they'd form to the shape of the fender. Not much radius, but there's a little bit. And so after I got that one on, it's in a place that I like. It's gonna get trimmed. The headlight's too high. It's gonna get trimmed. Then I came back and I screwed on, or I clamped on these 2 aluminum bars. Those are familiar, those were the hood bars. Then I measured back from the grill shell to here and to here. Then I measured from the back side of the grill shell to here and the back side to here. And got as close as I could. I'm within a 1/16 of an inch. And the reason is because it's fiberglass, there's some variation, but I want the fronts of the headlights to be perfectly straight, and I want the view from the front I want that view to look right, and I want the side view to look right. So now they're standing out forward a little bit. I want to put on a crossbar, and I want to have a method of tightening the headlight up underneath, which will integrate with the crossbar, we'll cover that hole up. So now I'll tack that one on, and then I'll get my heights for the headlights, and then continue on. But first I want to get these bases on, and at this point they are where they need to be. So I'll tack that one now. Alright, so now 2 pieces. I just wrapped them with TIG, and they look good, they're sitting good, and I'll let them cool. And now I gotta figure out this. So the bolts came in through there. They were a carriage style bolt. Okay, set up in the top, and then you would adjust the headlight, you know, fore and aft, and then you could clock it a little each way. Not much, but you could actually rotate, you know what I mean. So the point now is then, how am I going to get those, not these, but something like this. And one of my thoughts is that, see, I provide an access point, got the ball on there, and provide an access point on here. You're like, the nut's going to be, on a 7/16 bolt, that's what that is. The nut's going to be what? Does anybody know? Does anybody know? The head's 5/8, the nut is 11/16. So once, wherever this is clocked, it's going to have an effect on whether or not I can get in there and tighten the nut. Of course, I don't need this much strength. This obviously, back in the Oldsmobile days, the way they mounted this was for a multitude of reasons. So anyway, I'm not going to need that size. I'm going to need that size of square if I keep that size of slot. So we'll keep dreaming about it. Oh yeah, and the wiring has to come through. We'll make it happen. Okay. Flange nut. And I didn't add filler. I just used a flange nut. Now you know why I went with the 7/8 OD on that. Just so I could stay tight. That sucker is hot. But I kept the plasma cut edge. I got low there, but I mean, kept the plasma cut edge and welded on the 2 flange nuts for the mounting. And just finished this one up. So now the base, the foundation of the posts is done, and we got to figure out how we can get some sort of a form, you know, in that 2-inch range. Still thinking about it. Okay, got them chopped off to stubs, and now yanked out the roller and the wheel. I made this, I don't know if I had this in a video, but I made this out of a just 14 gauge, but 3.5, 5.5, 5, 4. It's just a radius gauge, okay? So I wanted to accomplish a roll that was as close as I could get to this. In this case, that was a 4-inch radius. So I'm a little tighter on that one because I just started wheeling it, but I thought I better get a video. There you go. And I accomplished that by going into my tube forming die. This is static. You're just gently forming this shape in there, just bending it, right? Now I'm going to take this shape. I've identified the front on both pieces because that's where it's going to start, and it's a declining shape. So I'm going to start to wheel it until I can get a profile in it. So that's a declining radius, so it will tighten up as I go to the back. But in this case, you can see the pass direction. I went this direction to try to establish a little bit of stress in the top. You can kind of see a little bit of stress in the top. So now I'm going to start to try to tighten up the back and try to get some shape in there. So I'll get back at it. I'm using a number 5 on the bottom, 5-inch radius die on the bottom on the crown there to try to. This is of course larger than my largest, which is 7 on here, 7.5. This is a huge radius, but I'm just going to try to get it to set down on there. Wish me luck. All right, I'm close. There's the original piece, or the piece for the other side. So basically, you know, smacking it, you can see some hammer marks with a, in this case I used a crowned body hammer because I didn't want to get a whole bunch bridged 2 pieces. I could use a sandbag, but I'm not. This is a pretty simple operation. So now, and I haven't done anything, that's got some damage back there, so I'll rotate a little bit. I'll eventually fix that damage, but, and we are going to be, you know, right up or behind this edge. You can see I pulled a little, as I was wheeling it, I got a little excess radius in it, and I'm close, but I'm not dead on. But I am touching the radius. I am looking right. So I'm going to stop on this right now and make this one look like this one. This almost defaults to that far back, or that close up. And then I'll work some of these tings out. Once I have this shape looking like this shape, then I'll work these tings out, and then I'm going to come in here and strategically remove this. Now this one doesn't have rust through on the bottom. It's all shiny metal. Couple of tings here, so I might grab those. But I'll probably, you know, whatever shape I'm going to remove all the bolts, get rid of the socket, get rid of everything in here, and butt weld that into here. But that shape will be smaller, and what I'll do is I'll work that on the wheel to fit this shape. Then I can touch it with my radius gauge to identify low spots, and when I'm way in, you know, I'll weld it up. I might have to tink it a little bit, and then I'll get both headlights kind of put back together. So onto this one now. Okay, got them both made. Calling this thing, that's thing 1. This is thing 2. This is headlight, headlight 2 and headlight 1. Headlight 2, let's just get them laid up here. Evidently had more dirt time in the last 90 years because of that, and you can see the light shining through. It looks like a freaking pumpkin. So I copied the profile of the shape. I know my radius up in this section here is a little wider, so I can conservatively, you know, I need to stay in color inside the lines. However, I want to taper this because it's so much easier to form or shape as I get closer to that. And I collected all the holes within the boundaries of my replacement piece. In this case, I'm going to stay just inside the edge. You can see I got more distance here than up here, in the event that this material is too thinned out. This one looks to be in good shape. It's got the standard run-of-the-mill, you know, corrosion up in this area, but I'm not seeing that's a crack right there. So this one I might take right to the edge, maybe put a fill piece in there or something like that. I'll get rid of those, but I'm going to start with this one, get it tacked in and shaped, and then if I'm confident, I'll go to this one. And earlier I said something about a bag and stuff. I pounded it over 2 4x4s. I don't have a bag that holds sand anymore. I need to get one, and surely that would have made this faster, but just the same, I got my profile, you know, just following the light line here a little bit. It stays pretty consistent. So, and I will be doing a little bit more shaping on it. So anyway, in any event, I'm going to go ahead and start cutting this up and get back with you. So now, I got the whole structure out. I didn't lose shape. You can see I got some holes right here. I'll need to address those a little bit later. But I'll just clean up the edge now. But I'm going to take the opportunity, since I have access, see that? Since I have access to start dollling out some of that with my big hole. There are more holes. There are more holes. Let's see if I can. But I'm going to touch each one of those If I can touch them with the TIG, I'll do the TIG, but usually the results are shit because you'll have to go in and, you know, drill a hole. So maybe if I touch them with the MIG and sand them down. The nice thing is that now you can count them all up, you know. There you go. There's 1, 2, 3, maybe 4 right there, and I'll get those. But at this point now, I guess I'm going to get this into a condition where I can single-handed stuff, where I can see, just open that up a little bit, get that shape in there. It's looking good, but I just want to get that profile in there. The nice thing about this being a little tight on the radius is that I can draw the line inside, right? Knowing when I open the radius up, I'll have to trim. So I can get that sucker in there in slow and steady increments. So anyway, I'm gonna jump on that. Well, probably a lot of you guys, folks, have done this before. But I've always, where I've got a pinhole where I want to see if it's going to run, I use the MIG. And if it runs, the material's so thin, you know, you try and try and try, and then pretty soon it goes away. In this case, I decided I'd try with TIG. So I took the material and cleaned it with a finishing pad, just to get all the scale and rust off. And then I touched it with a TIG. And I didn't think, I thought I'd be throwing sparks and everything, you know, simply because of the fact that the rust would contaminate it. But it went all the way through, did the flashlight trick and everything, and so that worked. If you haven't done it, try the TIG. The thing is you can come in slow, right? You can come in slow until the metal starts to molten. Drop your bead on the hole, or as close to it as you can, preferably on the hole, and then spread it out. So it did work. Well, one down and one to go. I did start with TIGging. I got my shape, started with TIGging, and it started closing, and I didn't maintain the control that I needed to maintain. I couldn't even tack it in several spots. It just started closing the gap, and then it started opening on this side, so I stopped and moved over to MIG. A lot more grinding, but I did get penetration. Got a wonderful profile. You know, it worked out just stellar. When I grind it down, I'll go with it. But I started at the bottom, right? Can't really get a clamp in there. I got, you know, a long clamp that I used for the most part, but just doweling and going, and lost control of it, but that's not a big deal. I got it back. I got the process back into control, but I got a nice narrow signature because I did create a gap, use my cutoff wheel, and got that 40 thousandths gap in there so that I could slowly TIG it on 18, right? Just use 18, or, you know, very low current, and slowly work it. Then, of course, shine the light in it and found a few more holes, so I plugged all those holes. I just did those with the MIG, you know, just as long as I had it in my hand, I was going to finish it up. So I'll grind him up and then move on to that one. Well, quick recap. Started as this, cut this out, and made that. You can see a hint of it in there. But, you know, there's still a lot to go. I dinged out much of this. Got this pretty good. I just didn't. It's very hard to swing even when you have, because I'm not cut all the way back. And I got similar damage on this one that I'll pop out. But I'm happy with that. Looks good. So I can begin to build the bracing and stuff for the mount after that. Well, I fought it and fought it and fought it. This is the second one. Got a little low spot there, and I fought the top and the side. But they came out good, really good. But I'm going to have to do a little bit of dollying and sanding. But I'm going to sandblast them. Anyway, I'm going to sandblast them and get them to white metal. Clean them up after I finish fabricating the mounts. But now we have two. And I tinged out the best I could. I used a long bolt and just kind of kept rocking this on the bench as my dolly and popped it out. It actually came out good, quite good. Once I get it sandblasted, it's got the profile to it. So this one just turned out really good, and this was the one in the worst shape. No rust holes to fill in that one. I just, for whatever reason, I got my profile. I learned as I went. I used this as the image to lay it on top. Not to cut it out, but to lay it on top, to copy it. I got the copy, but instead of on this one, I came up, I tack, and came up, and then came up, and then finished the bottom later. On this one, I did the bottom first, and then I progressively just clamped and moved up, and this sucker up on the top just, kept falling in. Should have stopped and got a couple of tacks on the top, but the shrinkage on the second one was not as prominent as on the first one. But for whatever reason, I hate saying that, for various reasons, I just fought it. I should have tacked it in several spots. I had the right profile, but I didn't. Anyway, that's okay though. In the end, it's fine. It's just that this took me probably a good 10 hours to do these two. That's a long time. Okay, after cutting out a 14 gauge bracket and a 10 gauge bracket. Okay, they're just sandwiched. Nothing is welded. They're just sandwiched with a couple of 1/4-20s holding the works together. Then I took 2 pieces of angle, measured the center to center on these side holes, and attached this angle. Now, these side holes are horizontal, but I established after some review last night that this is on the top and that hole right there is on the very bottom. So I took and stuck these cans straight up on the bench, came up with a square, and made a mark on each one of them. I established that. So on this one I have the hole, but on this one I welded all the way up. The material wasn't good on this one. This one was the worst of the two. So in order to do that, I just set them on my bench. I took a straight edge and ran a line. Okay, I used those holes, these holes, and identified the center line on those 2 holes. Looking down the side, I set each one of those cans on here. The distance didn't matter. Relative to that, then I put a straight edge on here, made this mark, and that represented each edge of the 2 cans. Okay. I found the center line of that, of these 2, and identified the center of that diameter. Okay. Then I took a straight edge laying on the bench straight up, did both of those. So now I have these 2 lights, but I need to get them to set on the pedestals. There we go. They don't set super snug, okay, but sit on the pedestals, and I need to tie those together. Use a 2-foot level or whatever and some clamps. Tie those together and get them this way and this way the same. So that's what I'm going to work on right now with those pieces of angle. Once they're the same, I'll tack each one. You know, adjust it until I get it right. Tack each one on. Then rip that off and I'll weld the bottom flange, it's 10 gauge, to the 1/8 inch DOM pipe, and I'll tack it 2 or 3 places, then I'll take it off and TIG it on. Okay, then I'll have each of those sides completed. I'll then go and tack the 14 gauge to the 18 gauge. Okay, and those studs will come up through and they'll nut on from the inside. I'll weld these studs on to that, I'll TIG that onto that, and then they'll come to the inside. So the headlight will remove, but now my wiring channel's there. My headlight will sink in. Again, my adjusters will be on the surface of this headlight. Instead of adjusting the whole headlight, the headlights will be static, and voila, this portion of the project will be complete. I am going to order the adjusters. I don't have them, and I'm just debating on whether or not I should keep the headlights in the cart, but they are headlights with you know, the ring around them. Can't remember what it's called right offhand. But the LED ring, and I probably will have to build the trim ring unless I can find one, because I think they're going to stick out a little bit, and I think this ring will need to be like 1.5 inches So I don't know exactly what I'm going to do yet for that, but we'll see that. So I have to order the headlights, so um, we'll get going. And then after I get those two in, then I'm going to build the, I don't know the exact shape, but I'm going to build the crossbar, the Chrysler crossbar. All right. Okay, car's level. Car's been level both ways. Still sitting on the stands from when I started all of this. This car hasn't moved for a year. So all I really needed to do was get these guys straight ahead. Use those. I lined a sight on the back side of the level. You know, and I could measure the front side and all that kind of thing to get that level. They are through the center line, so they're clocked this way. That controls that way, and then they're level. Okay, and then the question is, where should I put them? So I put both of them at, I'm not gonna, I put both of the, I put that on this edge, made sure it was flat, and I clocked them both down 2 degrees. Now, even though I have a design ride height and all that stuff with this car, we all know that 2 degrees is not very much, but we know that our headlights don't go straight out into the abyss, right? So I'll have adjustment to go even farther down, but this car does have a modest rake, and that angle is 3 degrees. It's not a lot. So that's a total of 5 degrees down, but I'll be able to adjust them from there. Better than horizontal. You know, that's my logic. If I'm wrong, I'm wrong. The spacing between the radiator grill shell is beautiful. The parallelism, of course, is there. I eyeballed it. I got a good hour into all this. So all that is ready to go. See the weld, the ground. I tacked them, 3 tacks on each one of them. Now I know they look high. I mean, to me, they look high. Of course, the hood's going to be on there. They're on the lower half of the side of the hood line from the radiator, or from the fender up to the top of the radiator grill. But those are going to get more substantial now, because when the 3D printed part is created, it'll be this width, right? It'll transition into this length, if you can see the nuts under there, and there, to cover all of that up. So now these bolts will get, these studs will get welded onto the 10 gauge. The 10 gauge will get welded up to there. The headlight will be removable. The headlights are the same. So, you know, going from side to side and keeping track of passenger versus driver is a non-issue. If I want additional adjustment, obviously I could shim, you know, under here, under the gasket surface, but I don't think I'm going to need it, because I will have the adjustment in the rings, and I did order those rings after that last little excerpt. What else? Now I got to make a piece on here to make the crossbar. I'm going to jump online, look at a couple of 30 Chryslers, whether it bends out or up and over, in, out, you know, whatever it does. I want to get something on there that will bolt in, probably with a couple of number 10s on each side. Okay, we'll get after that.